Hello dear students, welcome back to my lesson. On today's video, I'm going to continue explaining section 1 in chapter 2. In the previous lesson, we have studied point mass and extended object. When does an object considered to be a point mass, and when does an object considered to be an extended object? In the case of when the object is moving in a translational motion, or when the object is moving in a linear or projectile or circular motion, in that case, the object has only translational motion. So in that case, we describe the object as a point mass. Okay, but for extended object, when an object is rolling or moving or rotating, in that case, the object considered to be an extended object. Only rotating? No. For example, when a bowling ball rolling down from an incline, in that case, the object has both types of motion, translation and rotational motion. So in that case, the object considered to be an extended object. So finally, we can say the object can be considered to be an extended object when the object has rotational motion, or when the object has both rotation and translational motion. But for the point mass, we can say the object considered to be a point mass if it has only translational motion, such as dropping ball or such as moving an object from one position to another position without rotating. Okay. In the second topic, we have studied the torque. Okay. The torque is a measure of ability of force to rotating an object through a specific axis. So, for example, when a force applied on an object, instead moving object from one position to another position, it is rotating around a fixed axis. In that case, the torque produces, which is equal to force times d times sine theta. Okay. If you remember, in grade 11, you have learned work. Okay. When does the work done on an object? When the force applied on an object and it goes to moving the object from one position to another position. The product of the force and the displacement and the direction of the component of the force to the displacement. In that case, the work is done on the object, and you can calculate the value of the work by using this equation, which is equal to force times distance times cosine theta. But in the case of rotational motion, when the force is applied on an object and it goes to rotating, such as this pen, okay, when the force applied on this pen, instead of moving, it is rotating, okay, rotating around what? A fixed axis, okay. So we can say torque is equal to Fd sine theta. So what does torque depends on? The amount of the force and distance from the applied force to the axis of rotation, and the angle between the distance and force. And also you can say the torque depends on the force and the lever arm and angle between force and distance. Okay. So also we studied lever arm. What is lever arm? Lever arm is a perpendicular distance. Perpendicular distance. Always perpendicular? Yes. Is a perpendicular distance from where? From the axis of rotation to the line drawn of the force. Okay. Or you can say that the perpendicular distance from the axis of rotation to the force, or to the extension of the force. Okay. So torque measured in what? According to its unit, it is equation measured in what? Newton per meter. So you can open Newton. Newton is equal to what? Kilogram meter per second square. This is Newton. If you open Newton, so you can get this unit. And what is remain? Meter is remain. Meter times meter, meter square per second squares. Also, the torque can be measured by kilogram meter square per second square, or measured by Newton meter. Okay. So on today's lesson, we're going to continue explaining section 1 in chapter 2, rotational dynamic. And as you know, we stop it here. For example, when the force applied in a tilted angle, not perpendicularly, as you can see in this picture, this force can be analyzed into two components. Okay, let's draw this. Okay. When a force applied on this spanner, okay, assume that this is axis of rotation. What is this? This is axis of rotation. If the force applied in a tilted angle, not perpendicularly, as you can see in this figure, what is this? This is force. This force is not on the x-axis and not on the y-axis. It is between x-axis and y-axis. Okay, so assume that this is original point. Look at me. This is y-axis and this is x-axis. This force between y-axis and x-axis. As you learned in grade 11, if the force makes an angle with x-axis or y-axis, this force will resolve into two components. Okay, so we can analyze this force into two components, x component and y component. Okay, in that case, because the angle with the x-axis, okay, for example, this is angle, this force can be resolved into two components, fx located here and fy located here. Okay, so in that case, because the angle with x-axis, according Pythagorean theorem, fx is equal to f cosine theta, and fy, this is fy, is equal to f sine theta. So look at here and pay close attention, please. So how many forces do we have now? Two, fx and fy. Okay, fy. So which of these two forces produces torque? Fx or fy and y? This is question. So if you look this figure, the fx, the x component of the force, it makes an angle 0 with the distance. Okay, the angle here is what? 0. Because the angle is 0, or the force fx, the x component of the force is parallel to the distance. This is distance. Okay, so that is why its torque is 0. Cannot produce torque. Fx cannot rotate this spanner. Why? Because this force is parallel, or you can say because the extension of the fx is passes through what? If you extend fx, it passes through what? Through the axis of rotation. So that is why fx cannot produce torque. Why? Because this component, x component force, has 0 degree with the distance, so that is why its torque is 0. But if you see the perpendicular distance, the perpendicular force, which is Fy, this force is perpendicular to the distance. Okay, so that is why Fy produces torque, which is equal to what? Fd sine theta. This is the theta between force and the dip arm, and this is force and this is distance. Okay, so which component produces torque? The y component produces torque. Okay. Note number 5, if the minimum force is applied, which means that the direction of the applied force is perpendicular. Okay, if the question says minimum force applied on the object to rotate the object, in that case you have to use 90 degree. Why? Because only in 90 degree, only when the force is perpendicular, you require a minimum force. Okay, but more than 90, less than 90, you require more force to produce the same torque. Okay, note number 6. Torque, like displacement and force, is a vector quantity, but in this book we will deal with the torque as a scalar quantity. Okay, we will assign each torque positive or negative depending on the direction of the force tends to rotate an object. When the object rotates counterclockwise, the torque becomes positive, or the torque going to be positive. But in the case when the object rotating clockwise direction, the torque going to be negative. Okay, such as we studied in chapter 1 about the angular acceleration, angular speed. It is direction, it is sign depends on the movement, the direction of the clockwise or counterclockwise. Okay, every clockwise direction has negative, and every counterclockwise direction has a positive sign. Okay, torque becomes positive if the rotation is what? Counterclockwise. Be careful. Torque is negative if the rotation is what? Clockwise direction. When the force is applied on the axis of rotation, D is 0 and torque is 0. How? For example, if you have a thin beam, okay, so this is axis of rotation. If the force applied on this axis of rotation, okay, if the distance of this beam is 2 meters, but the distance at this point is 0. So that is what, that is why torque is equal to 0. Why? Because the force acting on the axis of rotation, this distance is always equal to 0. Why? Because this distance in the equation of torque, which is equal to F d sine theta. What is this d? This is not the distance of the beam, not the distance of the spanner. Be careful, please. This distance is the distance from the applied force to the axis of rotation. For example, if the force applied at this point, at the middle of this beam, what is the value of d? The entire beam is 2 meters. But because the force acted at the middle of the beam, so that is why you have to take only this distance, which is equal to what? Half of 2 is 1 meter. Okay? To find the net torque, add up the individual torques. For example, if you have more than one torque, how can you determine the net torque? You have to add up all of them. Okay, so you have to pay attention for the sign. If the net torque is positive, it means that the object rotating counterclockwise. But if the net torque is negative, it means that the object is rotating clockwise direction. Okay, if the mass is given, it means that the object rotating according to the gravitational force, such as a bowling ball. If we release a bowling ball, the bowling is try to moving through the equilibrium position because of the gravitational force and produces the torque. So sometimes the gravitational force produces torque, sometimes the applied force and frictional force or many other force can produce torque. Okay, if the force applied tangent to the cylinder or disc, in that case R, which is equal to the radius of the cylinder, and disc is equal to the distance. For example, if you have a bicycle tire, what is this? This is bicycle tire. Where is the axis of rotation of the bicycle tire? Located at the middle. Okay. Okay. So in that case, when the force applied tangent of the bicycle tire or cylinder or disc merry-go, for example, this is force. Okay. Where is distance? The distance in that case for the cylinder, for disc, bicycle tire, ring, merry-go, you have to count from the axis of rotation, which is this point, to the edge of the ring. Okay, so in that case, this is R, and also this is D. So the equation becomes like that. You can say instead of D, you can write R sine theta. Okay, it's no problem. It's okay. Why? Because this is the radius of the bicycle tire, and also it is the distance from the axis of rotation to the applied force, and in that case, this is perpendicular. Okay. If the angle is not given, force is perpendicular. Always you have to use theta 90 degree. When does theta is 90? If the angle is not given, or if the question doesn't mention the angle. Okay. If the angle is not between the force or the extended force, then you need to change or find the angle between force and D. So this is very important, guys. Be careful. Look, the equation of torque is force times distance times sine theta. What is this theta? This is angle. Angle between what? The angle between force and distance. In the case when the angle is not given between the force and the distance, in that case you have to try to find the angle between force and distance. How? Look at this example. For example, if you have a beam, okay, this is axis of rotation, okay, and if the force applied in this direction, okay, the beam tried to move in clockwise, counterclockwise or clockwise, because this is the upward force, so that is why it's gonna be counterclockwise. The beam gonna be counterclockwise. Why? Because this is upward force. Okay, so this force can produce torque. Yes, of course. Why? Because this force is not parallel to the distance. Okay, and the angle between force and D is tilted angle. Okay, But if the angle is given with this normal, okay, where is this is distance. What is this? This is distance. What is this? This is normal, okay? If this angle is given, for example, 50 degree, okay? So, you have to convert this angle. Why? Because this angle is not between force and distance. This angle is between force and normal. But the equation of torque says F times d sine theta, but this theta should be between distance and the force, the arm and the force. So what can you do in that case? You have to try to find what? Find the angle between force and d. Where is d? This is distance. Okay, what is this? This is the distance of the beam. And where is force? This is force. Okay, we have to find this angle. How can we determine this angle? Because between the normal and the distance there is 90 degree right angle, okay, 90 degree, 90 minus 50, 90 minus 50 is equal to 40 degrees. So in that case you have to use FD sine 40 or 50? 40. Why? Because 50 was not given between force and distance. 50 degree is between force and the perpendicular line. The normal, okay? So, is it possible to find this angle? For example, between force and this, is it this between force and distance also? Yes, of course. Both are correct. So, how can you determine this angle? Here we have 50 degree, and here we have what? 90 degree. 90 plus 50 is 140. So, is it possible to write down FD sine 140? Yes, absolutely you can do it. Yes, of course. Okay, because sine 40 is equal to sine 140. Okay, sorry, this is 130. Sorry, 130. Okay, both are correct. The most important thing here, you have to think about that this angle, it should be between force and D on the arm. Okay, so this is the angle between force and arm, and also this is the angle between force and the arm or the distance. So this is very important. Pay attention, please. Okay, so we have two cases about that, to converting the angle to the between the force and the arm. Okay. So in each of the following example, the cat is pushing on the same door at the same distance from axis and with the same amount of the force, but different what? Different angle. Okay, they have the same distance. Okay, same distance, same D, and same force. Same distance, same force. Look, this is axis of rotation, the force. Okay. And also this is axis of rotation, this is D, this is axis of rotation, and this is D. But what is the difference between these three cases? The only difference here between these three pictures, as you can see here, is the angle between the applied force and the lever arm. As you can see, this is the force of the car. This force is perpendicular to the distance, yes, so it means that produce most torque. So, is this angle is perpendicular? No, this is not perpendicular. This is more than 90, so that is why it produces less torque. So, if the angle increases or the angle away from the 90, the torque becomes less and less. So that is why it becomes the least torque. If they bring in the Vizari exam, be careful and pay close attention, please. Which of the following figures produces most torque? Figure A. Okay. Which of the following figures produces the least torque? Figure C. Because of what? Because of the angle. If you assume that this angle is what? 90, sine 90 maximum. This angle, I think more than 90, let's say 110. This is less than, this is less torque. This angle is approximately near to the 180, but it is not 180, okay? Let's say in the case figure C, the angle is 150, for example, okay? So, in that case, be careful, FD sine theta. torque is directly proportional to sine theta? Yes. But with the magnitude of the theta, not with the angle. So, which one has more torque? 90 degree, 110, 115. Which one produces most torque? 90. Be careful. Don't say 150 because theta is directly proportional to the torque. The torque is directly proportional to the angle with the magnitude of the angle. What is the sine 150? Less than 1. What is the value of theta 150? Is less than 1. What is the sine 90? Is 1. So that is why produces maximum torque. If you see this question in the Wizari exam, which of the following, look, which of the following produce, which of the following lever produce most torque? A, D sine 150. B, D sine 75. C, D sine 105. D, both B and C. Which of the following is correct? In that case, you have to find the value of sine 150. What is the value of sine 150? We have to calculate by calculator, which is equal to, just a moment, sorry. Sine 150 is equal to half. Sine 75 is equal to 0. Approximately 966. Sine 105 is equal to the same 0.966. So which one is bigger, 0.5 or 0.96? Absolutely, this two has the most torque and maximum torque. So you have to choose D, both B and C. So both B and C, they have the same value. Why? Because 75 is a 15 degree, has a 15 degree difference with the 90 degree. 90 minus 75 is equal to what? Is equal to 15. So 105 minus 90 is also equal to 15. So that is why they have the same value. Okay, but in that case, 150 minus 90 is equal to what? Is equal to 60 degrees. So that is why, which one close or near 90 degree? The 15 degrees. So you have to say which of the following produces the most torque? Which of the following angles? The angles who's close to the 90 degree. For example, which of the following has most torque? 120 degree or 70 degree? Absolutely the 70 degree. Why? Because the difference between 70 degree and 90 degree is 20 degree. Okay? But the difference between 120 degree to the 90 degree is 30. So that is why the angle with with the close to the 90 degree produces most torque. When does an applied force cannot produce torque on an object? When a force acts on the axis of rotation. Why? Because when the force acted on the axis of rotation, its distance has become 0. So that is why no torque produces. Okay. or if the angle between force and the distance 0, 180 or 680 degree. Here we have some questions from chapter review. Look at question 2. Question 2 in chapter review related with this section. As you know, I'm going to solve all the questions of the chapter review. Okay? So for example, when we're finishing this chapter, we already solved all the questions of the chapter review and the section review. Okay? Because this question related with this section, so that is why I solve it here. Okay? Which of the forces acting on the rod in this figure, as you can see, produce a torque about the axis at the left end of the rod? Where is the axis of rotation? This is axis of rotation. Which force produces torque? F2 or F1? F2. Why? Because F2 is perpendicular to the distance, so that is why produces torque. But which one has more distance, D1 or D2? D1 bigger than D2, but F1 cannot produce torque. Torque is equal to 0. Why? Because the angle between force F1 and D is what? Is parallel. 0 degree. Sine 0, 0. So that is why no torque produces in that case. Okay. Question 5. Two forces of equal magnitude act on a wheel. How many forces do we have? We have two forces. Okay. Look. Let me magnify the picture. We have two forces here. Okay. And as shown in this figure, which force will produce the greater torque on the wheel? Look, how many forces do we have? Two. Okay, so both forces are applied at the same position. Okay, which one has more distance? Same. D1 is equal to D2. F1 is equal to F2. Because the torque depends on the distance, force, and the angle between them. Which one has more angle? Theta 1 has 90 degree, but theta 2 has less than 90 or more than 90. The same, okay? So which one produces more torque? Perpendicular force or the tilted force? Absolutely. The force that perpendicular to the distance produces the greater torque. Okay? Because theta 2 is less than or more than 90. For any angle, when it is more than or less than 90, it has less torque. When does the torque has maximum value? In the case when the angle is 90 degree or when the angle is 270 degree, because in both cases theta becomes 1. Okay, so which one produces the greatest torque? F1, absolutely. Why? Because it is perpendicular to the arc. Question, sample problem 2a. Look at this question. This is sample problem 2a, a very good question. Okay. So the question says, a basketball is being pushed by two players during tip-off. One player exerts a downward force, as you can see in this figure. So this is the axis of rotation of the ball. Okay. So the first force is downward force. Okay. This is the force. Okay. Applied at this distance. So this is the distance. Okay. F1 was given 11 Newton. As you can see in this figure, when the force applied on this ball, the ball is rotating clockwise direction. Okay, so torque number 1, it should be negative. Why? Because it is rotating clockwise direction. So the second force, as the question said, so 11 Newton at a distance 7 centimeter. This distance is what? 7 centimeters. So the force applied on the 7 centimeters. So it means that D1 is equal to 7 centimeter, which is equal to 0.07 meter. Okay. The second player applies an upward force, 15 Newton perpendicular to the distance. This is distance. Okay. Upward force perpendicular F2. This force also produces the clockwise direction of the ball, so that is why torque number 2 is also it's going to be a negative. Why? Because it is rotating clockwise direction. But F2 has value 15 Newton at a distance of, which one has more distance, F2 or F1? Absolutely F2. Why? Because the question says D2 is equal to what? 14 centimeter. Okay? Which is equal to 0.14 meter. How many torques do we have? We have 2 torques. So in that case, we have to find what? The net torque. Find what? Net torque. Why? Because we have more than 1 torque. How can you determine net torque is equal to torque number 1, torque number 2? And the net torque, it should be negative. Why? Because both torques has negative sign. How can you determine torque number 1? Torque number 1 is equal to F1 D1. Its angle is what? 90 degree. In both cases. So that is why not necessary to write down the sign 90, okay? Because it is equal to 1. Replace. F1 was given, yes, negative. Why? Because it is rotating clockwise direction. 11 times 0.07, okay? So torque number 2 is equal to what? 15 times 0.014. Torque number 1 is equal to what? 11 times 0.07 is equal to 0.77 Newton meter. Torque number 2, 15 times 0.14 is equal to 2.1. So net torque approximately is equal to what? Is equal to negative 2.9 Newton meter. Okay? So why this is negative? Because the net torque is because the both torques are rotating in the direction of clockwise direction. Okay. At constant torque, force and D is always inversely related. So according to the equation of the torque, torque is equal to what? Is equal to FD sine theta. F is equal to what? F is equal to torque divided by D sine theta. What is relation between force and distance? The relation between force and distance at constant torque. Be careful. When torque is constant, what is relation between force and D? Is inversely proportional. So if two forces or two distances are given in the question, how can you determine the relation between the force and the lever arm? By using this equation, which is equal to F1 over F2 is equal to D2 over D1. Okay? If the distance decreases by factor half, how the force changes when the torque is constant? Because the distance becomes half, the force becomes twice as much. Okay? And so at constant D and sine theta, the force and torque are directly proportional. Okay? So look at this question. If a door handle is in the middle, okay? If the door handle is in the middle, to open the door, the force needs to be what? To be twice as much. Why? Because if we decrease the distance of the handle door, look at this picture. For example, this is the handle of the door. In the first case, this is D1 and F1, okay? But in the second case, if we change the handle of the door into the middle of the door, so what happened to the distance? The distance becomes half. So it means that D2 is equal to half of D1. Okay? At the same torque, so F2 is equal to how much time is bigger or less than F1. So we have to find F2. How can you determine F2? By using this relation, because F is inversely proportional to the distance. So that is why F1 over F2, it should be equal to D2 over D1. Okay, why here we have 1, here we have 2? Because they are inversely related. Okay, so F1, bring down F1 over F2. D2, and instead of D2, write down what? 1 over 2 D1. 1 over 2 what? D1. Divided by what? Divided by D1. D1 with D1 cancel. What does remain? F1 over F2 is equal to what? 1 over 2. Cross multiplication. F2, 1 times F2, F2. 2 times F1, 2F1. So, what happened if we decrease the distance of the handle of the door, and if we change the handle into the middle of the door, it means that we decrease the distance by factor of half. But by which factor is it force changes? By factor of 2. So the force must be increases by factor of 2. Okay? So vice versa is true, be careful. When we say the door handle is in the middle, which means that D becomes half. Okay? D2 is equal to half of D1. Okay, guys. So what happened if we change the handle of the door to quarter of its initial distance? For example, if the handle of the door is here, we have D1 and F1. But if you change the handle of the door to 1/4 of its initial distance, okay? What do you mean by 1/4 of? So this is the axis of rotation, okay? This is axis of the rotation, axis of rotation. Less distance require more force. Why? Because distance with the force is inversely proportional at the same torque. To open the door, the handle of the door, it should be located at the edge farthest from the axis of rotation. Why? Because more distance require less force to open the door. In that case, what happened to D2? Decreases by factor 4 or changes by factor 1 over 4. Okay, we decrease the distance of the handle of the door by factor of what? 4. Okay, F2 is equal to how many times bigger or less than F1? Because the distance decreases, the force must be increased. Why? Because F with D inversely proportional. Less distance require what? More force. How can you solve this? You have to say F1 over F2 is equal to D2 over D1 because they are inversely related. Okay? So, F1 over F2 is equal to what? D2. Instead of D2, write down what? 1 over 4 D1 over D1. D1 with D1 cancel. What does remain? F1 over F2, 1 over 4 divided by 1 is equal to 1 over 4. Cross multiplication, 1 times F2, F2. 4 times F1, 4F1. So, if you change the handle of the door to the quarter of initial length, you require more force and the force becomes quadruple. When does the force becomes quadruple of initial force? It is initial force if the distance decreases by factor 4. If the distance of the handle becomes quarter of its initial distance. Question 1, practice 2A. Look at this question. Very good question, and this question has been brought this year in preparation test, okay, when they did on March, okay. How can you solve this question? A simple pendulum consists of what? 3 kilogram point mass. Mass is given in that case. Mass of a pendulum is 3 kilogram. Okay, let's draw the pendulum. This is pendulum. Okay. The mass of this bulb is 3 kilogram. At the end of 2 meter long high string, the distance of the string is 2 meter. This distance is what? 2 meter. D is given, which is equal to what? 2 meter, okay? That's connected to the pivot. This is pivot. What is this? This is pivot, which is axis of rotation. Okay, so the bulb sleeve, the bulb which is rotating around this point. So this bulb is rotating because of the gravitational force. So in that case, the gravitational force produces torque. We have two unknowns in this question. A, calculate the magnitude of the torque due to the force of the gravity. due to the force of what? The gravity. Why? Because mass is given. Around this pivot, when the string makes 5-degree angle with the vertical, pay close attention please. They make his angle with what? With the vertical. Where is vertical component? This is vertical component. Where is the horizontal component? This is horizontal component. Where is D? This is D. Okay? So, this angle with the vertical, yes, which is equal to what? 5-degree. Okay? So, is this angle between force and the distance? Yes, of course. How? Because the gravitational force is always downward. What is this? This is Fg, which is equal to mass times gravity. Okay? So, can we say this is the extension of the distance? Yes, of course. According to math basic, these two angles are the same. This is 5-degree and also this is 5-degree. What is this? This is distance? Yes, this is distance. This is force? Yes, this is force. So, can we change this angle? No, 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 no. Don't change this angle, please. Don't convert this angle. Why? Because the angle is between what? Distance and force. But if the question says, calculate the magnitude of the torque due to the gravity around this pivot when the string makes 5, or it makes, for example, 85-degree with the horizontal. If the angle with the horizontal is given, you have to convert with the vertical. Okay? In the case when the angle with the horizontal is given in this question, you have to convert to the angle with the distance with the angle between the force and the distance. But in that case, don't convert the angle, please. Okay? Why? Because the angle is already between what? The distance and the force. So that is why you are not necessary to convert this angle. Okay, now how can you theta 5-degree? Calculate the magnitude of the torque, which is equal to, according to gravity, during the gravity, the torque produces Fg sine theta. Torque is equal to, instead of Fg, write down what? Mg. When mass is given, you have to convert to weight, which is equal to mass times gravity, d sine theta. Mass was given 3, gravity 9.81, distance of the string was given, which is equal to 2 meters, sine what? Sine 5. Okay? This is branch A, which is equal to what? 5.13 Newton. Newton meter, sorry. In the second branch, you have to use the same step, but instead of 5-degree, write down 15-degree. Mg d sine theta, but theta here is 15-degree. Question 2. If the torque required to loosen on the wheel of a car has a magnitude 14 Newton meter. What is this? This is torque. How did you know? By the unit. Torque was given is equal to what? 14 Newton meter. How did you know this is torque? Because of the unit. Newton meter is measured for the torque. Okay? What minimum force? What do you mean by minimum force? As I mentioned before in the notes, if the question says minimum force, it means that angle is 90. The angle between force and the arm should be 90. Why? Because only in the 90-degree we require a minimum force. More than 90, less than 90, you have to use more force to produce the same torque. Must be exerted by mechanics at the end of 30 centimeter. Distance was given in 30 centimeter, which is equal to what? 0.3 meter divided by 100, convert centimeter to meter. Range to loosen a knot. So it is very easy question. Just plug in, write down the equation of torque, Fd sine theta. F is equal to what? Torque over d sine theta, which is equal to 4t divided by 0.3 times sine 90 perpendicular. The angle is not given, so that is why we have to use 90-degree, which is equal to 1. Okay? So the force that required to loosen this knot is equal to 133.33 Newton. Okay? Question 8 in chapter review. We have a cylinder, a bucket filled with water and a cylinder. So I wrote the note here. If the force applied on the pulley DC gun cylinder, in the case of FD sine theta or FD, you can write down mgr. Why? Because this object rotating according to the gravitational force. Okay, so that is why the gravitational force produces torque. So in that case, instead of force, you have to write down what? Mg. A bucket filled with water, as you can see in this figure. Okay, the mass of the bucket is 54 kilogram. Okay, actually this is not logically because this bucket is very heavy. Okay, it should be 20 kilogram or 10 kilogram, 15 kilogram, but okay. According to this book, they said this bucket has 54 kilogram and it's hanging from a rope that is wound around 0.05 meter radius stationary cylinder. This is cylinder, okay? So sorry. So this is the bucket. So this bucket is moving downward because of the gravitational force, which is equal to mg, okay? And the radius or the distance of the cylinder from the axis of rotation, r, which is equal to d, is equal to what? 0.07 meter. So this is radius, or this is the distance from the axis of rotation, okay? Mass of the bucket, 54 kilogram, okay? If the cylinder doesn't rotate and the bucket hangs straight down, what is the magnet of the torque? The bucket is around the center of the cylinder. We have to find the torque because this force is perpendicular, okay? So that is why the angle between force and the radius of the cylinder is 90 degree. Torque is equal to what? Fd sine 90. Torque is equal to, instead of F, you have to write down mg, d, and finally is equal to 54 times 9.81 times 0.05 and equal to 26.5 Newton meter. Okay. Question number 9, very good question, please. Be careful and listen carefully. Question 9, a very good question, and it has been brought in Wizari exam many times. Okay, so that is why you have to listen carefully, please. The question says, the arm of the crane at construction site is 15 meters long. What is this? This is the arm of the crane. Okay. This distance is 15 meters from this point to this point. Okay. This is what? The distance of the arm. Okay. Great. Now, distance is 15 meters. It makes an angle of 20 degrees with the horizontal. Where is horizontal? This is vertical axis and this is horizontal axis. The distance, the arm of the crane makes angle with what? With horizontal or vertical? With horizontal x-axis, which is equal to what? 20 degrees. The angle is given between the arm and the horizontal x-axis direction, okay? Assume that the maximum load crane can handle is limited by the amount of the force the load produces around the base of the arm. A, what is the magnitude of the maximum torque? What is unknown? Torque is unknown, okay? Torque is unknown. Can withstand if the maximum load of the crane can handle is 415 Newton. Force was given 150 Newton. So this is the load. The load of the crane can handle, which is equal, this is force. This is the gravitational force. Is equal to what? 450 Newton. Okay? What is this? This is force. Okay? And what is this? This is distance. Okay? In the equation of the torque is equal to what? Fd sine theta. Do we have force? Yes, was given 450 times. Do we have arm distance? Yes, 15 times sine. Sine what? Sine 20? No, be careful. You have to convert this angle. Why? Because this angle is not between distance and force. This is not force, guys, be careful. This is force, no, this is horizontal. This angle between D and horizontal, we don't need this angle. So we have to convert to what? The angle between distance and force. What is this? This is force. What is this? This is this. And what is this angle? Can you find this angle? Yes, of course. 90 minus this angle is equal to this angle. Why? Because this is perpendicular. This is right angle triangle. You can, if this angle is given, you can find this angle. Why? Because 90 minus 20 is equal to 70 degrees. If you add up all of them, you have to get 180 degrees. Okay? So, which angle can be used? 70. Sine what? Sine 70. So, this is very good and very, very good question, and you have to pay close attention, please. Okay? And you have to calculate is equal to what? Sine 70? 6,343 Newton meter. Okay? The second branch, for the same torque, we have to find the maximum load. We have to find what? Force for the same torque. But in this case, the angle is 40 with the horizontal. We have to convert this 40 to what? To 50 degrees. Which one has more, which one requires more force? 70 degree or 50 degree? Which one close to the 90? The 70 degree close to the 90. So it means that this angle requires less force. But this angle requires more force. Why? Because sine 50 is less than sine 70. So that is why this angle requires more force, which is equal to what? 552. Okay, compared with the branch A. In branch A, the force was 450 when angle is 70, but in the branch B, the angle is 50, so that is why it requires more force. Why? Because force is inversely proportional to sine theta. More, when we say sine theta, it means that the answer of the sine theta, okay? Question 34. Question 34. In the chapter review, the torque required to loosen a node that holds the wheel on a car has what? Has a magnitude of 58 Newton meter. What is this? This is torque. 58 Newton meter, okay? What force must be exerted? Force is unknown. Exerted on what? Exerted at the end of 0.30 meter log range, distance 0.35 meter to loosen a node when the angle is 56 degrees. So how can you determine torque? Just by replacing into the equation of the torque Fd sine theta. Do we have force? No. Rearrange. Force is equal to what? Torque over what? D sine theta. Do we have torque? Yes, was given 58. Distance 0.35. Angle sine 56, which is equal to what? 200 Newton. So we require 200 Newton force to open and to open this node. Okay. So we finished this section, and now I'm gonna, inshallah, in the next lesson, we're gonna solve these questions in the section review, in section 1, chapter 2, and inshallah, we will start explaining section 2 in chapter 2. Hope you get benefited, and thank you for listening. See you again, inshallah.